Welcome back to Wickerson Studios. I have just put in, continuing along after doing point objects and point clouds in the curve menu of Rhino. I've just put on in GH Basics Curves 003 the single line through the vertical to C plane. And how that works is basically these functions which work normally in the Rhino environment are now brought into the grasshopper canvas, and grasshopper canvas get a little heavy here, so it might be good to grab all my scripts and turn them to disable, and that should allow us to flow in here a little faster. I think it'll be fine. So basically I have a little bit of baked object here, which is kind of fun. How did this little object get made? Pretty interesting when we get into it, and I'll show you how that's done. What I'll do right now is just take it off and go to shaded and show you that we just start with something pretty simple. Zoom extends all. And what I've done is I've gone in, what I started with was the Rhino command single line and showed how to create that line segments, and then I went on to perpendicular from curve. And this is where it gets pretty exciting. So I think the best thing to do is actually just jump into this file, and I will turn it back on for now, enable, so you can see all these complex things as they're running. If I put on my oscillation tool and get things active, it can get pretty fun. Things start to move a little bit like machines. And if I put on my oscillation for my bake tool over here in my playground, that can be pretty fun as well, and you can see that generating that geometry, and it's gonna kind of really go out there as it starts to have its sine and cosine coincide with one another. And I've got some nice colors in there, so if I go over to render, you see that you end up getting this kind of parametric color coder gradient map as well. So that's a fun little script that's just going to generate a bunch of things as we're looking. But basically, I just ran down the list, did line segments, did perpendicular from curve. What I do is I output the geometries, but I also show the functions and how to come to that function through a little bit of scripting. The purple are where the scripts are, the reds are where the parameters are. And I'm just going to zoom out here so you can see that things are kind of being generated here in a more complex fashion. Rhino can handle it. If you're dealing in lines, yes, I have a few pipes in here which slow it down a little bit. But I did a tangent from curve. All of these nodes are pretty close. Sometimes I have to do some funky work with dot product, which was kind of fun. And that's where I ended up making this pretty interesting script over here that involved a little bit of GHPYTHON. I thought it might be good to go in here and have a little bit of a GHPYTHON script. You couldn't write too much of an easier one. I'm going to take that off and you'll see how easier it is. It's just a conditional that if x is between 0.1 and 1.1, then a is set to true, and then that will activate the bake. So it's only when I get within a number of the dot product that I actually want to see. So that's kind of it, and you'll see how it kind of clicks on and off and runs into bugging problems as it goes. But otherwise, it's a nice little script. You can always grab what you've been baking in here and delete it and start fresh again and see what it's cooking up for you. It's a messy little thing, but it's also really fun to get your head into mapping and geometry in 4 dimensions. So that's kind of fun. What else did I do? Tangent from curves, tangent from 2 points, tangent perpendicular was kind of fun. Once again, playing with the dot product to get close. And as long as my numbers get close to 0 and close to 1, then I know that they're perpendicular. You could have a more accurate model if you wanted to, but what I like to do is kind of get close and then kind of bake that form into Rhino. It's not the perfection that you can achieve in computational design, but it's kind of fun. Very simple angled bisector tools. The 4 from point tool was kind of nice because I just used a circle, and if I take that script and put that one on and take everything else off, I just have to unbake all this nonsense, and then you can see that I've got this kind of a circular pattern here, but this bake is really getting in my way as I go, which is kind of fun as a distraction, producing these geometries. But you probably want to take that script and put that to disable, and then you want to clean up the script that you actually made so you can have a look at what's actually happening. So we'll go back into here, and I had what was it again? It was the angled bisector from 4 points. Just grab that script through here. And you can see that from a gene pool, if I have my 2 points dictating the length of that line, so 4 points are dictating not only the line that goes in, but the extension of those lines. And it's a pretty interesting script because it'll come back on itself and open itself up and produce 2 lines. So using a circle as a pattern with a gene pool, you can actually generate some pretty interesting geometries. I do like to use gene pool a lot. And then I think I have here a point. I'm not sure what happened here. I pulled it off of my, not sure why I pulled that off of my graph mapper. Kind of blew up on me. Let me just grab a param geometry graph mapper. I think it's in utilities, isn't it? It's an input. Graph. No, I don't have graph mapper. I want a multidimensional slider. MD slider, let's just take that one and put it in there. Get rid of this one. And we'll introduce this one, add, and that should get us into a pretty interesting points. There it is. So I can play around with a quad sphere with each plane that's been debrepped on each side and produce surface normals from that. And that's kind of a fun little tool to have. But it gets you understanding how to create and mimic the functions normal to surface, and then also vertical to C-plane. I just went vertical to plane, and it doesn't have to be C-plane or C-minus plane. It looks like a grade. This is one that will go back and do the same thing from those and generate a line with a different length on there as well. So I can extend that line from the surface normals, and that's dictate, and that's dragged and draggable by here as well. So I'm just using a quad sphere as an example to do that. So you can get through all of the functions right here in the yellow that are pretty darn close, not completely accurate to what's in the curve menu line item because I didn't go perfectly to tangent perpendiculars. The dot product is something that logically I have to come out the other way and do projections and mimic the scripts that are within those functions. But because, you know, Grasshopper's kind of playful, you may as well pick around with it. So I'm just going to grab some geometry, see what I had. If I grab all my geometries, you can see that we have this kind of interesting tool that's going and being used. And then if I wanted to dump on this last little script, which is always fun, enable, you can kind of jump in here and see how that one's really got some fun about how sine is used. And then if I bring down my sine rotations to something much less, like something as low as, well, 2. I haven't done that one yet. Clean up my geometries and see how that pattern's generated. It's a pretty nice form. So you get some really nice finesse on what you can create object-wise and bake in geometries. All this geometry is being baked into lines. And so if you're thinking like smooth curves and surfaces to mimic and loft afterwards, and you want something to be trigonometry driven, that's a really nice script for that. Anyway, that's about it. I was just going live, making a little video recording, playing around. When I hit stop, I'm going to throw it online, and that should be fun. Yeah, it's funny how it's there. I just love these shapes and these colors and these forms, which you can produce with a little bit of logic, like a very simple 12-node script to generate these geometries with a little bit of an oscillation pattern and very simple Python functioning to start. It is infinite. If you want to play around with this stuff, it could just be amazing. All right, so that's it. Thanks for watching.